Welcome to Towle Talks. Today we're going to get classy. Alright, so today we're going to talk about Java classes. We're going to talk about three different types of constructors, member variables, and public-private functions. We're also going to talk about the different modifiers, public, private, protected, and unspecified, and what they mean in Java. It's a little bit different than, say, C++ or other programming languages. So let's get started. Today we are going to talk about classes, and again this will be fairly quick as I expect you have already seen most of this before. Now I've created a new Java project with the main. We'll get into what, don't worry about copying this right now, we'll get to this a little bit later. The first thing we're going to do is we're going to right click on our package, go to new, and create Java class. Once I do that, this will pop up. You're going to label it, just because the class name is car, and then hit finish. I've already created it, so I'm not going to recreate it. Again, at any time, please pause the video if I'm going too fast. So I want to give you a quick overview of classes. Remember, classes are the blueprints that you're going to use to create objects. Here, pardon me, here you'll see that I have a little graph here. Public, protected, no modifier, and private. These are the four options we have for member variables and methods for our class. The member variables, you think of it like attributes for our object, like what color something is, what's the name, what's the strength, etc. And the methods are like what you can do with that object. If it's public, everyone can see it. If it's protected, only things inside the subclass, like from inheritance or the same package and the same class, can see it. If there's no modifier, it has to be the same package, subclass, package, and a class can see it, but not a different package for subclass. If it's private, only things inside this class can see these member variables. This is a little bit different than C++ and a lot of other programming languages, so I thought I'd just give this a quick point. So here we're going to have our member variables, pardon me, and here we're going to have four of them. We're private int engine, private string name, public static int count. Now this is a static variable, we'll talk about this in a moment, and public string color red. This is a public variable, so I can reference this on the outside, like such say in main. However, notice it's not static. Now that these four variables are going to describe my object. After I have these four variables, I'm going to have to figure out a way to construct the object from the main or from wherever I call this. So I have a couple different ways I can do that. One, default constructor. This will take no parameters. It's going to be a public, no return type, and then the name of the class, in this case car. Here I give the values that I would a normal vanilla form of this class. Oops. And again, nothing special here. I'm going to say 10 for engine, normal car for the name, black for color, and then count, I'm going to increment count plus plus. Notice here I initialize my static int count as 0, and you'll see what I'm going to do here, why I'm doing that. A second form we have is parameterized constructor. It's public car. Here I send in the information I want to feed the different attributes, and again I'm going to increment count plus plus. The third type of constructor, which I didn't actually talk about in class, is the copy constructor. Here I'm going to pass in an instance of this object that's already been created. I would say engine equals c.engine, name equals c.name, color equals c.color. Then I'm going to increment the count of how many cars by 1. Now, word of warning. This is only safe because string is immutable, which means it's going to do a deep copy. If this was an array, for some reason, or say this was like an array of different things, I would have to do a deep copy for my array here. Otherwise, this particular instance of car that was created would be pointing at the other car's instance data. And again, that would be a shallow copy, and we don't want that. So those are the three basic types of constructors I'm going to be using. Again, if I'm going too fast, please pause the video. Let me go back up there real quick, sorry. So, default, parameterized, and copy constructor. Now that I have those three constructors, I have to decide how I want to get stuff. So here I'm going to do my getter and setter functions. Notice I have private variables. I have public void set engine int e. You might ask yourself, well, if you want the public to be able to actually set the engine value, why would you just not make it public in the first place? And the reason I don't is here I can provide a little bit of protection. My parameter I'm passing in is e. So here I'm making sure e is less than 100 and e is greater than 0. If both those conditions are true, then it's a valid number. Otherwise, it's not. So here I say engine equals e. Set color. Same thing with color, although color is actually a public variable, so I don't even need this function. But I could pass in string c and then color equals c. Double check that is public. Yeah, public. Color is public. Yeah. Set return get engine. So here I return engine, the value of engine. Here I get color, I return color. Again, I don't actually need this because this is public, so I don't actually need this function. And then here I have public string get name, and I return the name. Notice I do not have a set name, which means once I create this object, I cannot change its name, at least directly. So there is no way to change the name on this object once I created it. Then here I have an example of a public function, public void drive. It'll print out the name of the vehicle is driving, and that'll be it. And then here I have a special function is toString. Now this one is going to be called anytime I try to print an instance of my object. This function is going to be called implicitly, and it will print out this. It'll call this, and the object will return this string as what it means for this object to be a string. In this case, it'll print out a nice little format. We'll see down here, name, engine, and color. We'll come back to this. So this is the class I'm using. Again, this is a special function. Here's a public function, and then here are my getters and setters. So I'll let you guys copy that down. Again, go back to the video if I've gone too fast. I'm sure I have, but this is just an example again of making a simple class. Next, we'll figure out how to use this class. So next, we're going to actually use the class. So we have our class all set up here. Let's go through this a little bit real quick, just in case you missed something. You can pause the video, and then the constructors. Variables, and then you don't have to copy this part down if you don't want to. So after we have that class, we're going to try using it. You can ignore this real quick. We'll go through this manually. So first things first, how do I what can and can't I do with static? So it's very tempting to think I can just do this, car.getColor, right? Well, I can't, because car is it's like using the blueprint. Car is a class, it's a blueprint, it's not the actual object. Therefore, it's a non-static method to get the color. There's no actual color. In order to get the color or to set the color, I have to create the object. So here we'll say, pardon me, car A equals new car. This will invoke the copy constructor, or the default constructor, pardon me. Now I can do system.out.println, and I just can print A. Because remember, this is going to automatically invoke the toString method, and this will print. One thing I'm going to do up here is I'm going to do system.out.println, the number of cars is, and I'll say cars dot car dot count. Now I can use count because count is a static variable. That's like, so I'm using the blueprint itself and not the actual object I'm creating. So every time I create a count, I'm adding like a little tick mark on my blueprint so I can get information from the blueprint. Here, I'll just copy and paste that line and we'll see what we're up. So here, the number of cars is 0. Here, normal car, engine's 10, color is black. That's what we'd expect. Again, this is being called from that toString method because I'm printing an instance of my object. So just implicitly calling this function. Then I go back, and print the number of cars is, cars.count, and you'll see that the static variable has increased by 1. So this is a good use for having a static variable, is to count how many times you created an instance of that object type. Now if I want it to be a special car, I could say car B equals new car, pass in maybe, I'll use a different number here. Say 70. 75, we'll say Corvette, and then we'll say red. String. This is a parameterized call, so I'm actually passing in the values I want my car to be created with. So now if I do system.out.println, and send in the object of my car, you'll see that I've created a custom car. And this metaphor actually works because this would be like you went to the dealership and actually custom ordered a special car for a special reason. So now name is Corvette, engine 75, color is red. Now, the last constructor I have is the copy constructor. So we'll say car C equals new car. Here I'm going to pass in B, which is the Corvette, but I want to change it. I want to know that it's different. So what I'm going to do is I'm going to say C.set engine, and for some reason this is a weaker Corvette, so we'll say 35. Here I'm going to do system.out.println, send in C, system.out.println, send in B. This will show you that it does in fact make a deep copy. So I run it. Now I see this is the first print from this line up here. This is the second print, Corvette 35. This is the new car I've created. And then this car here is from the original B, and it has remained the same. So this is how I can do a really easy way of duplicating or cloning a car. Again, in the copy constructor, if I have any arrays or objects that have been dynamically created, well, actually any objects that are not immutable in my class, I have to make sure I do a deep copy. Now, once I have the instances of my class, I can call any of the functions that are available publicly. So we get engine, get color, get name. I can also just get the color directly because it's public, so I can do system.out.println, a.color, whereas I cannot do this, system.out.println, b.engine, because engine is private. And you'll see it'll give me an error, and I look at the error, it says engine has private access. Same thing occurs with methods. If you make a method private, you cannot access it from main. Funny enough, I can make everything protected, and because everything's inside the same package, I could see everything inside that class. But public and private are very well demonstrated here. So now that I run it, now I see black. This is from the color, just getting the color directly from the first car. That's what I'd expect to see. So that is a quick overview of classes. Again, if I use, one more thing, I'll do system.out, I'll copy that. Yeah. The number of cars is cars.count. We'll run it again. you'll see the number of cars is 3 because we've created 3 separate cars, and each time I've incremented the static variable count, and now each of them have been incremented by 1. So this is an example of how the static variable at work. So again, if it's a static variable, I can reference it from the class name car dot. If it's non-static, either member or variable, I have to use a constructor to make a new car. Then I have to use that car's name, A, B, or C in this case, to actually invoke the non-static functionality of it. I hope that clears up any questions you guys have. But please play around with classes and make sure you understand what's going on. Thank you for watching this video. I hope you learned something and enjoyed it. If you did, please leave a comment or a like below. And again, thank you.